gig to 10 gig. Okay, we change from 1 gig to 10 gig because this is a must for your business. Okay, to have efficient network. Okay, high-speed network. Okay, for you to do your operation, to make sure your so-called company is efficient. Okay. Next, we also talk about the last part is talk about the network capability. Okay. Now, network switches has been around for many years. Again, there are also some issues with the network. Okay, very common issues, some like where the IT people will face. Okay, so I hope today's sessions will help you guys learn something and take back some of the things. So let me do the next slide on the company profile, a quick one on AEM. So we are a Singapore company. Okay, it's listed in the stock exchange. All right. So our company's core business is more on the automation in the manufacturing for smart chips, 5G chips. Okay, company like AMD, Intel. Okay, uses our product, but the automation that we produce are more for testing purpose. Okay, it's not like conveyor belt or robotic or so on, but mainly for testing of the product in terms of temperature testing, in terms of connectivity testing, and so on. So AEM core business is making automated system level tests. Our company comprises about close to about 600 people worldwide. Okay, so most of our people are, a lot of them are engineering background, hardware, software. Okay, so this company is core competency is a lot of so-called technical know-how in terms of development and creation of so-called this system test. Our headquarters is in Singapore. Okay, so we have various offices in different continents, in Europe, in US, as well in all Asia Pac. You can go to our website to learn about more about product. Okay, so we provide more on the testing application. All right, we do thermal testing, we do automation testing, optical inspections. Okay, software integration and test solution. So I come from AEM, and our department is basically making more on the cable tester solution. So today, I would like to talk about the product, what we call the AEM. Okay, let me see if I can show. Okay, can't see my mic. So today I'm going to talk about this product called Network Service Assistant. Right. So this Network Service Assistant, okay, is a combination of few test applications. Not just you do cable tests, but you also do network connectivity tests as well. Okay. So this tester is very unique. Unique in the sense that this is only one tool. Okay. It's a one set of tools that allow you to do all the level 1, layer 1, layer 2, and layer 3 testing in the OSI layer. So we call this tester a qualification tester, a qualification plus. Okay, in the market there are many kinds of testers. Okay, although some testers can do cable tests, but their cable test is very limited to just Wiremap. So when you look at tester, you have to look at the function it provides, the detailed information that it can test. Okay, so there are testers which we just call verification, qualification, qualification plus, and certification. Certification is the highest level of tester. Okay, so this NSA, Network Service Assistant, is a qualification plus tester. Okay, so you can see on the left column, these are the various so-called applications that you can test. Okay, not only we do cable test, we do signal integrity test, we do the network test, and also doing PoE test, which I will go through one by one. Okay, so this is the qualification plus test. Okay, So the component of this tester is very simple. You have a main unit with the adapter, the one that mounted onto the top of this unit, and a terminator, a small terminator to close the cabling connection, right? So in TIA standard, there's this standard called the 1152. 1152 is a standard for all cable tester. So one of the tester is what we call the single end testing. That means you only need one unit to test, while the other end is using a terminator. So this cable tester, we call cert-like testing, is compliant to the TIA standard 1152. Okay. This is another set of solution that we provide, where this is what we call a certification tester. Those who are in this certification field know, okay, that you need a certification tester to submit warranty. Warranty to who? Cable manufacturer. So if you are using CommScope cable, if you are using Belden cable or Pendant cable, when you finish a cabling system, okay, and in order for you to get their warranty, you need to submit the test result. And the test result that they accept are from certification tester. Certification tester, you need 2 units to test at both ends. Okay, so today we are not really talking about this certification tester, but more on the NSA.
这都写完中文没有来呢？
Yeah, or you need to mute, sorry. Okay, so just an overview on who will be using this NSA. Okay, usually end user, consultant, and actually sometimes system integrator also use NSA. Okay, but contractor and cable installers who are doing certification, they need this TestPro unit, which is very different from NSA. Okay, so if you need certification, if you need to submit warranty, you have to go for TestPro unit. But if you just want to have a assurance, testing that your cable is working, testing that your network is working, NSA is good enough. Okay, so this is a very unique tester that allows you to give you a very good so-called qualification of your cables and network, and it comply again to the standard. I think this is a very common chart. Okay, basically this chart is to show you, you know, as the signal speed, okay, year on year is going higher and faster. Okay, you need higher bandwidth as well to support all this kind of Ethernet speed. You know, especially in data center, we see the growth and the speed is growing tremendously. Okay, and especially now when people work from home, okay, they require good connectivity. So we see a growth in data center, in cloud services, and so on. Then in order to get good connections to your connected equipment, they need to have higher bandwidth, higher speed. Okay, so as we go along this growth, okay, testing is more critical because as you go higher speed, the demand for good cabling performance is very critical. If you have a poor cable performance, you will not be able to support the speed itself. So this is a thing to look up for as we want our cable to perform for future application as well. So you can see that as we go higher data, as we go higher power, okay, we see that a lot of devices are connected up. Okay, it's not just for the IoT device, okay, but as well for the network as well, for your internet connection as well. Okay, so there are a lot of applications that need to ride on good cabling. Okay, that need to make sure that your bandwidth of the cabling is good. Why go for Cat6a? Okay, why don't go for Cat5e? Okay, the difference is between of the different bandwidth. Okay, so if you remember some of the theory like Cat5e, they allow you only go 100 megahertz, you can see. But Cat6a gives you up to 500 megahertz. Okay, so As your data rate needs your data traffic, okay, need to travel faster, you need a wider bandwidth. Okay, so this is very important to keep in mind. If you are installing a new project, always go for the latest cabling system. So what are we going to touch on today? We're going to touch on three layers of OSI. Okay, so you know the OSI layer, right? There are 7 layers. Okay, starting with physical, then your data network, presentation, transportation, sessions, presentation, application. Okay, but today for the NSA model, I'm going to touch on 3 layers, that how we test these 3 layers. Okay, we're going to talk about how we test physical, which is the cabling. Now, physical is not just for cabling, but also for Wi-Fi as well. Okay, when signal can travel over copper cable, signal can travel over fiber cable, or signal can travel over Wi-Fi as well. Okay, then you have the layer 2, the data, how the thing is connected. Okay, how the protocol, how the packet is sent. All right.
Yeah.
So third layer, which is the network switch. Okay, so we're going to talk about how NSA can support testing to all these 3 layers. Regardless of which market you're from, okay, you can be in the hospitality, you can be in a hospital, you can be in the data center, okay, you can work for a military, a government organization, or in education, okay. Every market require cabling to connect their network, okay, to connect their network for their network equipment, to connect their network, to connect the cable to their security system, to connect their cable to their IoT devices, building sensor, building automation, and so on. Okay, but if you're running a critical application, for example, like banking, okay, you want the banking to make sure that it works all the time. You go to the ATM machine, you can draw your money. You go to banking facility, they won't break down. Okay, so this is what I'm saying, critical. Like hospital, they can't afford to break down. Like data center as well, it has to run 24 hours, 7 days a week. Okay, so when you run critical application, your cable cannot fail, your network cannot fail. Okay, because it is very, very serious damage if you fail, not just to the customer, but also to your revenue and cost. Okay, so as you think about critical application, you know that you're running on the physical layer. Okay, so this is about introduction, setting the platform, about importance of cabling and testing. Okay, then we're going to talk about troubleshooting of network cable. Okay, so network cable is all around you, whether in your home, in your office, in the shopping mall, in hospital, there are always network cable below the raised floor, above the ceiling. Okay, so when the contractor installer do the cabling, okay, they have to make sure that it's all connected, make sure it's laid correctly, okay, make sure it's tidy, okay, and then at the end of the day, after they finish, they will do the testing. Okay, so copper cable is the most common cable used in the market. Okay, why copper cable? Because the equipment that support copper cable are relatively cheap compared to fiber. Okay, and copper is sufficient for any building services. Okay, so it is very important to know about cable testing, because when you go to visit a site like me, I think in the past when I was working with Belden and Simon, I do a lot of audit. Okay, so sometimes the condition of the site could be so-called very chaotic, okay, very messy, okay. So you may not know what's going on during installation, okay. So it is very important to test when the cabling is done, okay, to ensure the cabling is done correctly. Then we come to the key topic, okay. Now, when it comes to failure, okay, based on my experience, there are many issues many so-called parameters that can fail. When we test copper cabling, okay, we measure a series of different parameters. Okay, we measure the length, we measure propagation, delay skew, crosstalk, return loss, insertion loss. Okay, we measure quite a lot of stuff in the cable. Okay, but from my experience, okay, there are three common failures which I always come across. Okay, first is the wire map. Okay, majority of the cabling failure is just form of wire map issue. Can be didn't terminate properly, wrong color code, and so on. So this mistake is quite easily to resolve. Okay. Then there are two common failures in the parameter which you will encounter most of the time. Okay, which I would say maybe 25% of your time, or 30% of the time that you will encounter this problem, which is crosstalk, which is called NEXT, near end crosstalk, or return loss. Other failures are very minor, okay, which today I just want to talk about these three major failures. Okay, so it helps you to understand if you have this failure, what is the necessary thing that you can do, okay, to ensure to resolve this failure. Wiremap. Now, how you get wiremap failure? Sometimes wiremap failure is sometimes when you terminate the cable to the connector, you didn't punch in all the way, or the IDC did not cut through the blade, cut through the cable to have the connection, or in the middle of the cable in the jacket, you damaged or cut through the cable. Okay, that's why you could have open or you could have short. Okay, or sometimes you could have reverse pair or cross pair. Okay, it is very common because, as you know, inside this cable there are 8 wires. Every wire has different color. Okay, 4 of them will have solid color. Solid color in terms of blue, orange, green, and brown. The other 4 wire will have white or blue, white or orange, white or green, and white or brown. Okay, so the color code is for you to terminate to the right so-called port, okay, or IDC, to ensure that you have the right wiring layout or wiring scheme. Sometimes people can't see the color carefully, could be orange and brown look the same. Okay, that's why they have cross pair or reverse pair or even split pair. Okay, so it is very important to ensure that the termination is correct. So if you have failure of wiremap, okay, first you have to understand where is the location. Okay, where is the location of the failure? So if I go back to the slide, if you look at this screen on the tester, okay, so if there is a wiremap failure, it can tell you the location or where it failed, whether it's at the main unit or at the remote unit. Okay, so if you look at this display here, so it says 2 meters from the main. So from the main unit, okay, 2 meters away from the main unit, that is the point of failure. Another failure could be shielding. Sometimes you have a shielded cable. Now, shielded cable is actually more common now than unshielded. So sometimes people do not know how to terminate the shield. Okay, so there are foil shield. There are also the drain wire inside the cable that you need to do proper grounding to ensure to close the loop. So if you don't do the proper grounding, you have open shield. Okay, so shielding can also cause wiremap failure. Okay, so wiremap is quite easily resolved. Just basically you have to find out what is the issue, where is the location, and you can do the re-termination. But if your cable is cut or broken, okay, do not join back. Okay, you have to replace the whole cable. All right. So this is more common remedy or how to resolve wiremap issue. Then we come to the one of the biggest headache we call crosstalk. Okay, so crosstalk, what does it mean? Means it is noise. Okay, near end crosstalk. So now I'm talking to you as a presenter. I present and you only hear my voice. If someone didn't mute, okay, or if let's say my background, okay, my background, let's say there's some noise, right? Like I'm banging on the table noise. Okay? So this noise interfere my speech, interfere my signal. Okay, it create a crosstalk to my signal. Okay, so crosstalk is not a good friend of your signal. Okay, if you're running 1 gig or 10 gig, this noise can interfere your signal transmission. So noise you have to resolve. Okay, so when you have failure, okay, when you measure cable and you have failure in crosstalk, crosstalk can be also far-end crosstalk, power sum crosstalk, anything related to crosstalk. Okay, so what are the crosstalk cause? So you see some of the picture below. Okay, sometimes your cable tie could be too tight. Okay, that it so-called squeeze the cable. Okay, so you have to imagine inside the jacket there are 8 wires, 4 pair. So imagine the 4 pair is being squeezed together tightly. Okay, there's no space in between. Okay, so it can have interference between each pair and can create high crosstalk. Okay, so if your cable tie is too tight, you make sure you have loosened your cable tie. Okay, so sometimes when you do termination, okay, you untwist your cable too much. Okay, then it also can cause crosstalk. So what are the possible causes I listed down? Could be poor untwisting. Okay, you need to untwist, but you untwist too much to do the termination. Okay, or sometimes your plug and your jack mismatch. Mismatch means that you could use a different kind of connector plug, okay, or the connector jack, okay, the plug is mismatched. Okay, mismatch in terms of impedance mismatch because of there's a different copper gauge, okay, between the jack and the plug, or poor quality of flash cord. Okay, so not all cables are made the same. Okay, that's why there's so much price differences in the market. Okay, so every component that you use to ensure that comply to the standard. In order to know that comply to the standard, testing will tell whether your cabling system is made with compliant to the standard. Okay, could be split pair. Okay, could be used inappropriate or coupler. Sometimes people want to join cabling. Okay, there are many interconnections along the cable. We know that in the cable you have maximum 90 meters from jack to jack, outlet to outlet 90 meters. In between, you can have interconnection as well, but you cannot have more than 2. Okay, if you have more than 2 interconnection, it can create a lot of noise as well. Every time the signal go through a transmission of interconnection, it creates some losses. Okay, so make sure you do not have a lot of interconnection. Okay, so as I said, cable tie as well. Okay, people like to squeeze very tight, which is good in the sense that it ties the cable, but bad for the cable signal. Okay, or sometimes you have external source of interference. Sometimes your cable is next to a very high power transformer. Okay, and it can create external noise interference. Okay, sometimes we call this EMI, electromagnetic interference. So that's why I say sometimes using a shielded cable could help avoid all this external interference. Okay, so again, every time you have a failure, it's always good to determine where's the location. Okay, where's the location? Do you need to re-terminate, or do you need to change the component, or change the cable as well? Okay, sometimes extreme bending. You see the picture on the right. Okay, so the contractor let the cable drop okay, like a waterfall drop, okay, without a proper bending radius, okay, and the weight of the cable kind of so-called exceed the bending radius, okay. So this kind of bending also create crosstalk, okay, and also check for interference source, ensure minimum untwist, okay. So for contractors, every time you have this failure, it is still resolvable. You can still resolve it by going through, make sure that you do all the troubleshooting. Return loss is also another secondary common problem that we see in the site. Okay, so return loss is usually sometimes caused by components. So sometimes we encourage you to use one brand. If you use CommScope, make sure your connectors, your cables, your jack, patch cord all come from the same brand. The reason is behind it is that the impedance. Okay, impedance of cables are measured in ohms. Okay, so why we say it is good to use the same brand? Because cable manufacturer, when they make the component, they have to comply to the TIA impedance measurement, which is 100 ohms. Okay, of course, not all the manufacturer can make exactly 100 ohms, and also the standard allows some variation. So the variation is plus and minus 15%. So what does it mean? So if you have a component that is 115 ohms, it complies to the standard. Okay, or if you have a cable that is 85 ohms, which is 50% less than 100 ohms, it still complies to standard. So there is a big variance between of the impedance. So when you have used a lot of mixed brand of cable and component, the impedance can be mismatched. That is what I mean. Okay, so make sure that you use the same brand and it reduces the failure, reduce the possibility of this issue. Okay, so the patch cord itself, I mean, again, we are talking about bending radius to make sure the patch cord have very good bending radius. Okay, make sure your cable don't have kinks. Okay, sometimes you see a knot on the cable line. This one can cause return loss. Okay, so do not squeeze too much cable in the conduit. Okay, that you know your cable become tightly fit in the conduit pipe. Back connector is also one thing. Okay, and so on. So impedance again mismatch, poorly matched plug and jack, or inappropriate auto test. Okay, so you have to make sure that when you have this failure, okay, you can determine using the cable tester to determine the location of the failure. Okay, so the tester itself, there is a fault locator for crosstalk and return loss as well. Okay, so the tester itself is a tool that is a very useful tool that can help you to test and as well as troubleshoot. Okay, so these are the three common failures which I want to touch on. Okay, for cabling. As I said, today's session is more practical. Okay, we will not go much into technical detail. Okay, but in terms of how to troubleshoot cabling. Okay, so there are also other failures that I didn't touch on. Can be propagation delay, delay skew failure, length failure, insertion lock failure. Now, most of these failures are very minor. Okay, which I don't want to go through because it can be easily resolved. Okay, so if you have any phases failure and if you think that you want to go through, please post your question on the chat group as well. Okay, and we can go through at the end of the slide. Okay, so I saw a lot of questions coming in. I will address it one by one after the slide. Okay, so thank you for the question. Please continue to keep coming in. I'm just gonna pop up your question in mind, you know, if you want to ask. So qualification of POE. Okay, so the POE testing is very unstructured in the market, in the sense that there's no one tell you how to test a PoE. Okay, there's no proper method. Okay, the only method that people think about testing of cable for PoE, there is only one way. In fact, there are many ways that you need to test PoE. Okay, so a little introduction of PoE is that we see a lot of devices, especially IoT devices, okay, in the building, in data center, okay, can be lighting, can be your security system, can be your Wi-Fi, can be your security system, okay. Some of the things now are going with PoE. It's very convenient for PoE. Why? Because one thing PoE eliminate is that the need for a local power supply. Okay, every devices that you put do not need a local power supply. The power can be carried through the same twisted pair cable. Okay, and PoE also can deliver the signal on the same cable. So it's very convenient. It actually saves a lot of cost for building cable infrastructure. No longer you need one cable for your security system, one cable for your data. In fact, the same cable can provide both services. Okay, so PoE are getting more in the building, so you see a lot of emergence of this requirement. Okay, and as the devices get, as we go to expand the usage for devices, now devices have different power requirements, from as low as low power of 15 watt to as high as 90 watt. Okay, why do we need high power? To support some of the devices that require high power, like for example the high power Wi-Fi or the high power camera. In the past, when we connect to a camera like CCTV, okay, it cannot support any camera with pan tilt zoom, okay, facility. Now, as we have higher power, you can support camera to perform pan tilt zoom. So the wattage will go higher. Is 90 watt the limit? I do not know. Okay, so again, there are a lot of standards that PoE, the community is working on to look at covering more and more devices. Next time your laptop can be charged using a 90 watt power. Okay, once there is a card built into your laptop, you can just plug in the RJ45 port to power up your devices. At the same time, connect to the so-called network as well. Okay, so you can see that it provides a lot of convenience without a local power supply. Okay, so PoE are very common nowadays. Okay, and when we talk about PoE, where does the power come from? The power can come from the switch, a power switch, or can come from the network switch. Okay, so there are two types that you can consider. You can buy a switch with power, or you can buy a separate, which is sometimes we call a different term, which I will show on the next slide. Okay. Now, the question when people run PoE, okay, is always very common. Okay. When I run PoE over a cable, okay, when I plug in the right power, but how come it cannot transport the power? At the end of the device, how come it cannot power up? How come the power drop? Okay, why the device cannot power up, even though I connected to a PoE? Okay. So if I run higher wattage, how come my cable get hot? Okay, so this is very common. Temperature will rise a bit on the cable, especially when you run high power. Okay, now so another question. As I run high power inside the cable, as I told you, there are 4 pairs. Some pairs are using for power, some pairs are using for data. Okay, will the power inside the pair affect the signal that running on the other pair? Will it cause high noise? Okay, So these are very common questions now, especially if you're running high power. So in PoE standard, okay, we classify into two types. Okay, it depends on where power comes from. Some buy a hybrid switch. The switch provides network data plus power. Okay, so we term this as the first one we call N-span. Okay, then the second one is that the switch is a switch, and then they have to provide an external power source, can be an injector, and this kind of configuration we call mid-span. So irregardless if you use N-span or mid-span, okay, it is basically you are running on the same cable platform that supply power and data to your devices. Okay, this is just form of understanding of the two types of configuration in the market. Okay, so people use mid-span because they want to add on to their existing system. For people who install new network, they probably go with N-span. Okay, so always remember, if you use the N-span or injector, you need additional local power source. All right. So this is a picture of your standard 4-pair cable. Okay, as you go high power, it requires all the 4-pair to support the wattage. But if you go for low power, okay, 15 wattage or 30 wattage, okay, you only need 2-pair, or the other 2-pair is for data. Okay, so it is still possible for data and power running on the same pair. Okay, so it is very common also. So this is based on the TIE standard running on the existing cable to ensure that if they want to support high power, how they use the 4-pair to run data and power concurrently. Okay, so look at the standard that you're using, look at the PoE power that you're using, so you understand whether they're using 2-pair or 4-pair. Okay. So what is the common parameter that's important for PoE? The last time I talked about PoE, okay, one of the critical parameter when we measure cable, okay, this parameter is called DCR, DC resistance. Okay, so DC resistance is one of the measurements in the cable based on impedance, based on ohm, based on ohm. Okay, this ohm, low ohm measurements, low DCR measurement, or high DCR measurement, okay, will affect how your power go through the cable. Okay, whether will it be like the diagram itself, okay, will not allow high current to pass through, or will allow high current to pass through. Okay, if you look at your power cable compared to the twisted pair cable, okay, the significant differences between the power cable and the twisted pair cable is the copper size. Power cable is usually very thick, can be 16 gauge or 18 gauge, or even as thick as 10 or 12 gauge. But if you look at your twisted pair cable, okay, usually it's 24 gauge, even smaller. Okay, now Cat 6 or Cat 6A, we are going higher up to 23 gauge. Okay, so the larger the conductor, okay, give you better or reduce the DCR measurement, DCR value, okay, which a lot more current to pass through. Okay, but you cannot build a Cat 6A that is 12 gauge or 18 gauge. Okay, it does not match with the connector. You cannot punch in at all because it's too thick. Okay, so in order to facilitate PoE, okay, one of the good best cabling system is go with Cat 6A because it's much thicker, okay, than the Cat 5E or Cat 6. Okay, so let's talk about the common issue that you face in PoE. Okay, one of the issues is that when you have a power source equipment, even whether it's an N-span or a mid-span, okay, you usually based on the requirement or the spec when you buy this equipment. Okay, either you want a 15-watt supply or you want a 90-watt supply. Okay, so even if you buy a 15-watt supply, okay, at the end of the cable, you will not exactly get 100% power. Why? Because of the DCR, because of the cable length, okay, there will be some losses. So it is acceptable for this kind of losses, okay? So you look at the last row called device power, okay, which is the minimum output at the end of the cable that you need to have in order to power your devices. So if you are using a 15.4 wattage, okay, your end of the cable, when you measure, you should get at least 13 watts. If you are using a 90-watt power at the end of the cable, regardless if it's 10-meter cable, 30-meter cable, or 90, the worst case, 90-meter cable, the minimum wattage you should receive is 71 watts. Okay, so not all cable testers are able to give you that kind of measurement. Okay, so in NSA, in this equipment, okay, if you plug to a power source, okay, the tester are able to determine the output. Okay, you're able to determine if your cable, okay, has high DCR or low DCR, and measure what's the output at the end of the cable. Okay, so this one kind of gives you assurance. If you want to plug a devices, you know that this will work. Okay, so it's a very simple measurement. You just plug in and measure. And if it's not giving you the right wattage or give you too low power, okay, either you need to change the equipment or change the cable. Okay, if the cable there's no issue, the DCR meets the TIA standard, you need to change the equipment. Okay, so this is good in the sense that give you assurance on what is the output of your PoE. Oh, I don't know why the picture did not show up. So the other common issue, okay, let me do the share screen again, reshare. I don't know why the picture didn't show up. Sorry for this interruption. Okay. It's the first time I encountered this issue. My original slide is okay, but I don't know why the picture didn't show up. Yeah, still didn't show up. Okay, doesn't matter. So another issue for PoE, which I encounter from some customers, is the power is not stable. Okay, so when you measure the power and when you connect it to the device, okay, sometimes the devices loses power because the equipment is not stable. So in the NSA tester itself, we can do a loading test. A loading test is basically, okay, to allow you to simulate, okay, during operation. That means you can connect to a camera if your device is a camera, or you can connect to any IoT devices that run on PoE. Okay, while the system is running, okay, with the tester itself, okay, you can test the equipment. Okay, you can test the equipment. That means, in other words, while you can do a real-time measurement, okay, to ensure that it is constantly maintaining the power that you require. Okay, so if you look at my display on the right the screen, okay, so you see the word called real power. Okay, so this power, this value will keep on fluctuating. It can drop a bit, go up a bit, drop a bit, go up a bit. It constantly measures to ensure that you have minimum power. Okay, so it's very important because you want to make sure that at the end of the day, not just your cable pass, okay, you have good power source, and also your system have constant power, stable power. Okay, so the unstable power could be caused by the equipment. Okay, could be caused by a lot of other issues as well, but majority is from the equipment. Okay, the other screen, okay, which I will talk about on my next slide, is the SNR. You see the measurement on my screen here called SNR. Okay, now this is what I will be talking about, how another issue of PoE. So the cable itself not just carry power, but actually it also carry data, either the 1 gig data or 10 gig data. Okay, so when the cable, when we always know this logic, right? Signal and power is always enemy to each other. Okay, they are not friends. Okay, if they are side by side, it could cause some issue, especially with power. Okay, because it can create noise, which classified again as EMI, electromagnetic interference. Okay, so another issue is signal interference. Okay, so using the same tester, okay, when the PoE is running, okay, and your data is running as well. Okay, so what you see here is we are measuring real time. Okay, we are giving you a real time measurement when your data and power is running at the same time. And when we measure the signal, we measure a value called SNR, which means signal noise ratio. So signal are referring to the 1 gig signal, 10 gig signal coming from the switch. Noise can be the noise coming from the power cable, can be coming from external noise, any noise that interferes with your signal. So the signal and noise had to be different levels. Signal had to be higher, noise had to be lower. Okay, so the ratio had to be positive. The higher the value you get in this measurement, it means that you have better immunity against the noise. Okay, so that is why people use a lot of shader. Okay, sometimes shader cable gives you better immunity against noise. Shader can be overall shield in the cable, covering the 8 wires or the 4 pair, or can be individual shield. You pay a little bit more for the cable, but you get better so-called protection against noise. Okay, if you have individual shielded pair itself. Okay, so you can see that PoE are not just cable measurement, but you also can measure the noise, you can measure the power, okay? You can measure the source and real time as well, okay? Which gives you a very good overview of this practicality when you want to run PoE system. So those in cabling, those in system line that provide security system, provide IoT devices, okay? You can tap on these devices on how to ensure that you get a good measurement when you hand over the system to your client. Whether the cabling is part of your work or not part of work, from this cable measurement, you can determine the cable are able to support the power as well. Okay, so we touch about cable issue, we touch about PoE issue. Okay. Next, we talk about multi-gig networking performance. Okay, so this multi-gig is talking about 1 gig, 10 gig kind of signal that you have in your system. Okay, so if you have a switch, okay, if you have a switch and you install a very high-end switch that's running 10 gig, let's say, okay, you want to make sure that the output, okay, connected to your device are not affecting the signal at all. Okay, so in our cable tester of NSA, we have 2 ports that allow you to measure ranges of 10 meg all the way to 10 gig. Okay, on the adapter itself, okay, which is on the top of the unit, can measure 2.5, 5 gig, and 10 gig signal integrity. While the side of the unit are measuring 10 meg, 100 meg, and 1 gig signal. Okay, so it's a measurement of your signal integrity. Okay, so why do we need to measure this integrity? Because cable can cause a lot of signal losses. Cable can interfere with your signal integrity. Okay, so I always like to use this analogy. Okay, every time when I talk about cable, to give you an idea on how important is cable. You know there is Cat 5e, Cat 6, Cat 6a. The difference between all these is the bandwidth performance. Okay, so Cat 6a gives you up to 500 megahertz. So imagine this bandwidth, okay, is the quality of your road. Okay, as you drive your car, whether you drive a Toyota or BM or Ferrari, okay, you want to make sure the road is smooth. Don't have pothole, don't have irregularity, so you can attain the good performance of the car. Okay, so the car is like your data rate, can be a 10 gig, 5 gig, or 2.5. Okay, you want to make sure your cable bandwidth for your road to be very smooth to ensure that when you send your traffic, send your signal over the cable, okay, you have minimum interference. Okay, so the tester allows you to measure the signal integrity. Again, the measurement is what we call signal noise ratio. Okay, the limit is 0. Okay, limit is 0. That means the noise and the signal is equal. So you get 0 dB. Okay, so this limit can be customized. Customized in the sense that as a user, you can set higher limit. Okay, you can set higher passing rate. If you set your limit to 3 dB, let's say you set your limit to 3 dB. So if you look at the screen, if you have 2.5, you will eventually fail if you set the limit higher. Okay, setting the limit higher gives you better performance. Okay, so you can see that various data rate give you various SNR. Okay, and at the same time, it again measure the PoE. Okay, if your switch comes with the PoE switch, right? So the tester itself is a multi-purpose tester, as I repeat again. It's not just for testing cable, it's also testing for your signal, PoE, and your multi-gig. Okay, so this is a very short slide on testing multi-gig. Okay, it is very important because if you're doing network, okay, you want to ensure that when you hand over to customer, everything is in order. Now we come to the last part. Okay, the last part talking about network. Now we come to layer 3. Okay, on the testing itself. Okay, so continue to ask questions in the chat group. Okay, I think Leo will help me to summarize all these questions. Okay, as I answer one by one. So continue to ask questions, even things that I don't cover here, but it's related. Okay, please feel free to ask. As this session again is a practical session, you may encounter something that I never share here, but do bring it up. Now this is more for people who handle IT. Okay, that they want to do a network. Okay, when we come to network testing, okay, this unit tester itself can do a physical or wired network testing as well as Wi-Fi. Okay, so what does it measure and how does it measure? Okay, so very simple and very overview of each of the capability that this tester can do. Okay. So when it comes to physical testing, okay, especially for IT people, they want to know what are the devices connected to the same cabling network. So it allows you to have auto discovery. It tells you how many network or how many equipment are connected, okay, to these devices. Okay, so you will discover, and even if with discovery, you can find out the MAC address, the IP address, in detail. Okay, as well as sometimes this cable is connected to which port of the switch. Okay, it gives you also the switch detail, okay, to tell you what brand of switch you're using. It can be a Cisco switch, Dell switch, HP switch, or any other brand that you're using as well. Okay, it conducts tests on the latency. That means is your signal, how much delay your signal has with the equipment. Okay, it gives you ping test and trace route, how the signal is being traced, okay, through the network. Okay, it gives you a mapping, right? And you also do auto test. So it's a very useful tool for those IT administrators, those who handle network. Okay, it gives you a very good cabling network overview of how good or how healthy is your network. Okay, so the function, okay, the function of this network tester, okay, give you very good information, right? So we go through one by one. Yeah. Oh, sorry. Okay, so you look at all this display, right? So as I say, do auto discovery, switch detail. It allow you to do ping. Okay, so you can see how fast your signal react or respond. Okay, it traces out how your signal going through one port to another port. Okay, it can create traffic. Okay, measure the packet size you send, measure the efficiency of your network. Okay, it also do VLAN discovery. Okay, and it gives you a full test, right, to see how healthy or how good is your network. Okay, so network testing on this NSA, it covers a full suite, okay, which is very useful, very deep, very good tool for those people in IT. Likewise for wireless. In terms of wireless, okay, you have also the same. Okay, you can connect to the SSID or the Wi-Fi devices that you want to measure. Okay, it can tell you how many networks connected to your devices. It gives you the signal strength of these Wi-Fi devices. Is it in the healthy range or is it in the weakest range? Okay, so it's very good information, okay, for this Wi-Fi. It do give you a network connection as well as all the SSID within the so-called premise, okay? So it do the same connectivity test as the Wi-Fi. That means it can do ping test, it can do trace route test as well, okay, for the wireless, okay? So these devices, as you can see, there is a lot of function that you can use, right? Okay, so going through all this, okay, we come to the report. Now, report is important again, okay? After measurement, you want to keep a record, you want to keep a documentation, okay? You want to pass the report to your customer, all right? Because at the end of the day, okay, it's a form of handover. It's a form to tell your customer, okay, I have installed the network, I have installed the cable, okay, and these are the measurements, okay, in good order, comply to the standard, okay. So it is very important at the end of the day testing, it is all recorded in the document, okay. So the report can be generated using the software, okay, software for you to generate the report. So this report software is what we call TestPro. Okay, so the report can be downloaded through the USB, transferred to the laptop, or even to the cloud. So if you have a Wi-Fi connection or a network connection, okay, you can download the test result to the cloud. Okay, so it allows you to upload, so you can download the result wherever you are from the cloud itself. You don't need to bring the unit out. You don't need to email the test result. Okay, you can upload straight to the cloud. So this is more practicality, convenience design for those people who need to download the test or upload the test result. Right. So the product itself is a very simple component. You have the main unit, okay, with the adapter and what we call a terminator, okay, all in the back, okay. So this is a qualification tester, as I say, okay. It's not a certification tester, okay. So that is basically the end of my slide, right? So I will go through the questions, okay. So if you have any questions, you can contact Zettabits, okay. You can scan the QR code for his contact, or you can scan my QR code for my contact, okay. I'm open for any questions, okay. You can WhatsApp me or you can email me after this is fine, or you can connect with Zettabits, okay, and ask them to have, forward your question to me as well, okay. So this is a quick session on practical again, more on troubleshooting, more on testing, okay, the necessary part that you need to do for your cable, for your PoE, for your signal, and for your network, okay. So we done about 1 hour sessions, which is about the time that I specified, okay. So now let's go through the question. So maybe I need Leo help to help me to list down what are the questions he has from the chat group.
Yeah, there's two questions inside the chat room there. Okay, the first one is the LAN cable run in the electrical riser got any issue on crosstalk and fail? If run in the electrical riser, what is the minimum spacing from their high tension electrical cable?
Yes. So there are standard talk about when you run cable parallel with power cable. Okay. So there are a few so-called scenario when you run parallel. So first, we talk about unshielded. That means you have unshielded copper cable, unshielded electrical cable. Both are unshielded. Okay. So if I remember correctly, based on the IEC standard, there is this standard from the European Standard Committee called IEC, which came out a spacing gap that you require to follow. It is to prevent some interference. It's not really a major concern sometimes if you run side by side, but to avoid, okay, to avoid in case, okay, there's interference, they actually require 0.5 meter to 1 meter apart if you are using unshielded copper cable and electrical cable. But if any of the cable is shielded, let's say electrical cable is shielded or your twisted pair cable is shielded, and if you run side by side with no spacing, it's fine. Okay. Another scenario is you have a separate conduit or piping for the cable. Then you can do side by side. So if you are using shielding, if you're using conduit, side by side is no problem. But if you're using unshielded for both, 0.5 meter to 1 meter, it is advisable. Okay. And sometimes people question also ask, in a system furniture, you know, when you have all the office, you set up system furniture, you can't avoid to have that kind of 0.5 meter apart. You have to run the cable, power cable and data cable in the system furniture in the same so-called spacing. That one is okay because that one is short length. So if you're running a short length, okay, less than 5 meters or less than 10 meters side by side, actually there's not much concern, even if you are using unshielded. So I hope that kind of gives you a understanding of this spacing. Okay. Okay, Leo. I hope that answer you. Yeah.
Yeah, there's a first, so we come to the second question there. So what is the accuracy of the PoE watt measurement?
The accuracy of the PoE comes from the power supply. Okay, so that usually some so-called spec of the PoE power source equipment that you buy. Okay, for example, if you buy an injector, it comes with either a 30 watt, 60 watt, 90 watt, or even a 51 spec. Okay, so the accuracy comes from the standard itself, the PoE IEEE standard. IEEE standard is that your output power, okay, output power should have a minimum. For 15 watt is 13 watt. For 90 watt is 71 watt. So this, I would say, is more or less the accuracy of the wattage. If you get less than that, okay, it can be two things. One is your power source equipment does not give you the right power. Second, your cable is no good. Your cable has high losses. Okay, so how do you determine that? First thing, you can plug directly. That means you use a simple patch cord, plug the tester to the power source on a short patch cord, so you can measure your output power. So this measurement will determine your power source equipment, is it good or bad. Second, if you plug along a 90 cable to measure the actual measurement, this one can determine if your cable is good or bad. So you do two steps. So that is how you measure the PoE. Yeah. So Yo, I hope that answered.
Ủa, cô có tiếng là nhập he. Cô có tiếng là nhập.
Okay, so we go to the third question. Yeah. Wow, there's a lot.
Yeah,
of
I saw the
now.
question now. So the question said, okay, I read the question. Run parallel side by side.
This
Okay.
continue to the first
So
one.
this is the same as I say. If you run a GI pipe or conduit, there's some separation. Okay, as long as there's a wall in between, there's a wall in between this power and data cable. Actually, it can be side by side. Okay, so the next one is, does the trunking carry network cable proper grounding with DC? Yes, again, grounding is very important. Okay, grounding especially for shaded cable. Okay, your shaded cable can be ground at the equipment rack or at the patch panel end. Okay, you need to ground one end. Okay, if your outlet end got no space for grounding, you need to ground at the patch panel end. So you need to ground. Okay, so every building will have a ground as a main ground. It can be an electrical ground or structural cabling ground. Okay, so it depends on where is your grounding, where is your main grounding. It will tie back to the main grounding. So TIA have a specific standard for all grounding. So the next question is that if got electrical bus duct inside the electrical riser, can network switches possibly be installed there? I think at the end of the day, I mean, sometimes in the building space is limited. So sometimes you look at the riser, wow, you can find a lot of devices inside the same riser itself. I think protection from the electronic noise, EMI, is very critical, and make sure that protection from any so-called what we call short circuit is also very critical. So it is also okay, if you have no choice and you have only one space to install your electrical switches, okay, it is fine. So when you install your electrical switches, okay, that space become a telecommunication room, okay, or we call a switch room, okay. So inside the switch room, there are requirements that how you should run a switch room, okay. So again, it's a separate topic. We talk about space require, separation require, lighting requirement for that space, okay, to allow you to manage the space, okay. So again, if you need to, you can have that TIA standard. We talk about space, okay. So if I remember correctly, the standard is called TIA 569. Okay, if you install electrical bars, your switches inside the same space. Okay. So he means that EMI again. EMI again is yes. If you run separate conduit for cables, it's fine. You can run side by side. Okay. Do we need to send the equipment? Yes. Okay. So the market standards or equipment tester standard is that every year you need to do calibration. Okay. So because it's a very sensitive equipment and because it's a field equipment, okay. So you need to recalibrate, okay, to make sure the measurement is still accurate. Okay. So this calibration, okay, usually is what we call a copper calibration to make sure that the measurement inside is still accurate. So it's fine-tune, readjust, okay, to make sure that everything in working order, right? So that is a calibration you need. Okay. So I think I covered most. I mean, there's so much questions. I was maybe if you have any question, just type in, or you can unmute. Okay, you can unmute your audio. Okay, you can ask questions straight. Okay. I think this Leo will send the video and the slide, okay, to everyone. Okay, this was asking, how about running fiber optic cable side by side? Fiber does not affect by EMI because it's glass. Okay, the signal are using light. Okay, so some people like fiber because at the end of the day, you don't need to worry about EMI. You don't need to worry side by side with fiber. Side by side with power cable. So fiber, the advantage is that it has it won't be affected by electrical noise. Okay. Yeah. So any other question you can unmute to ask. The session is basically for us to learn, and so whatever I know, I will try to share. What about Leo or Guo side? Got any question? I know there are a lot of concerns when you sign up, so I didn't go through that. So maybe Guo or Leo have any in that list.
Actually, most of the question that you have present already inside the slide lah. But some of the what we call the participant, they were concerned about the design stage for the cabling and the network. Okay,
so can this cable tester perform fiber test operation from Terry Tan? I hope Terry Tan is not the one in Penang, right? Yeah, I know. So yes, okay. So this is only one unit. Okay. In other words, if you do fiber testing, it has to be loop back. Hey, hi Terry, loop back. That means the in and the out or the transmit and receive have come back from the same tester. Because this is not a certification tester, you don't have the other end. So if you do a fiber testing, it has to be loop back to the same tester. So so if you talk about design of cabling today, we didn't talk about that. Actually, design of structured cabling is more on talking about how you design the horizontal, the backbone. Okay, how you make sure that the length within 90 meters. Okay, and we're doing zone cabling. I mean that this is a separate topic. So as I say, I mean today is more practical. It's more on troubleshooting, more on what is the purpose of testing, okay, and what we are testing. Yeah.
Okay, so for those who that you want to get the what we call the presentation slide from us, we hope that you can fill in the what we call the feedback form to us. So after that, then we will send the present slide for those who only reply the feedback form, because we also need to know any comment, any the feedback from this training here. So we hopefully we all can get all the participant can fill in the feedback form to us. And regard the video, we will going to upload in the YouTube. So if so before this, I have to get the permission from Dixon because this is the copyright from you. So is that okay if I upload the video to the YouTube?
Yeah, sure. So there's one question just came in, is that calibration done by manufacturer. At this moment, it's done in Singapore. Okay, this product is actually designed and built in Singapore. Okay, so I think you know so-called other common brand, most famous brand, Fluke. Okay, so the tester itself is catered for the same market. However, we don't call ourselves a cable tester, but a multi-function, because in this test itself, it tests the network, it tests the signal beside cable. Okay, so yes, we will download this, like what Leo said, we do this, download this video, okay, for you to go reference and in the slide itself. Okay.
Okay, so yeah, here is my boss. So Mr. Kwa is here already. So let me present to you. So Mr. Kwa is also the director of the Zettabits, and he also one of the cabling, what we call
Guru.
the design.
I think he's a cabling guru as well. I know.
Cabling guru lah.
Okay,
So, yeah.
I know Kwa for many years. We were ex-colleague. Okay. Even before we were ex-colleague, I know him already. So we have been doing stuff for many years. Yeah. So there's one more case. Sorry to interrupt you. There's one more question. Does it do cable tracing? Okay. So there is a fault locator. I don't know whether you call that tracing. Okay. It does trace where is the location of the fault. Okay. It does measure the whole length of the cable. Okay. So this cable tracing for this tester is what it do. It measure fault and it also measure length.
Okay, so Mr. Kwa.
Okay, thank you for all the participants attending to this very valuable training. And we also would like to take the opportunity sending our 1,000 or million thanks to our Dixon Tan, sharing this type of very good information. And we hope we will conduct the same more training in the future. Okay, I think we have one thing. Those who are asking for the slide, please fill in the feedback form. Only the feedback form we know who to send to. Okay, which email we can send to, because we have 100 old people have been sending to us they want to attending, and now actually we got about 70% or 60%, 70% people attending. That's why we want to filter out for those only attend to this training. We only send the slide to them. Okay, from the feedback earlier feedback. Can you allow me to share the file? Host, allow me to share the file.
I share here lah.
Okay. No, I think you allow me to share because I got some new amendment.
Oh, okay, sure. Wait, okay.
So while they are sending, I think I just want to take this time to thank everyone for attending. Okay, I think this is a very good session. So okay, thanks for summarizing this.
Okay, I think from the summary, I think that they got three things concerned summary lah. I put in the troubleshooting. Also, more people will say they need the troubleshooting, security, network failure, slow speed troubleshooting, and the PCBOE capability. This one I think they've been covered by Dixon, and some on the network side, the concerns. Their concern is. The concern actually is network down, slow connection, network instability, and the network is not stable. This will be qualified the multi-gate performance, network visualization. This will be on the network side. I think this will also, I should say, about 90% be covered by Dixon. We should be able to support by the NSA tester. Okay, and the other things they do have participants asking for the design, cabling, like knowledge, ELV installation, cable design, return loss, utility relocation. This one will be all to the structured cabling knowledge, and this will be covered in the future training. Okay, I will share the future. We still have on off those the courses were coming out, and other than that.